Welcome to this video on understanding the periodic table, key concepts and trends. We will cover the structure, key features, and reactivity trends of the elements. Our content includes an introduction to the periodic table, its structure, key features, and specific groups like alkali metals, halogens, and noble gases. We will also discuss reactivity trends and special element categories. This is the periodic table of the elements, organizing all known elements based on their properties. Take a moment to familiarize yourself with the structure and the key that explains the information in each element box. The periodic table is central to chemistry, displaying all 118 elements. Arranged by atomic number, it reveals periodic patterns and properties, helping chemists predict and explain element behavior in compounds. The table is organized into groups or columns, with elements that share similar chemical properties. Periods, or rows, indicate the number of electron shells, numbered 1 to 7. Transition elements form the central block. Elements are defined by their proton or atomic number. The principle of periodicity means that elements with similar chemical properties appear at regular intervals. Group numbers for I7 indicate the number of outer shell electrons. The period number tells us the number of electron shells. The majority of elements are metals, with non-metals on the right side. This slide presents an activity to test your understanding of the periodic table structure and the properties of different elements and groups. Group 1 consists of alkali metals, which are soft, silvery, and highly reactive. Reactivity increases as you move down the group, and they all form ions with a +1 charge. Alkali metals are not typical metals, being softer and lighter with low melting points. As you move down Group 1, density increases while melting points decrease. These gradual changes are called a trend. Reactivity increases down the group because atoms get larger. The outer electron is further from the nucleus and shielded by more inner shells, making it easier to lose in chemical reactions. Alkali metals react vigorously with water, producing hydrogen gas and alkaline solutions of their hydroxides. The reaction severity increases from lithium to potassium, demonstrating the reactivity trend. Alkali metals react similarly with chlorine and oxygen, forming chlorides and oxides respectively, which confirms their similar properties. Reactivity increases going down Group 1 because they all have one outer shell electron. The flame test is a method to identify metal cations by the color of the flame they produce. Alkali metals, like lithium, sodium, and potassium, each emit a characteristic color. Here are some additional questions to test your knowledge on the characteristics, reactivity, and uses of Group 1 alkali metals. Group 7, the halogens, is a non-metal group including chlorine, bromine, and iodine. Halogens are diatomic, poisonous, and have different colors. Moving down the group, density and boiling points increase. Halogens are among the most reactive elements. They react with metals to form halides. Reactivity decreases as you go down. Group 7, which is the opposite of the trend in Group 1. Halogens react in a similar way because all their atoms have 7 outer shell electrons. Atoms with the same number of outer shell electrons share similar chemical properties. Halogens are highly reactive because they need only one electron to complete their outer shell. With metals, they form ionic compounds. With non-metals, they form molecules with covalent bonds by sharing electrons. A more reactive halogen can displace a less reactive halogen from a solution of its halide. For example, chlorine displaces bromine from potassium bromide and iodine from potassium iodide. This final slide presents an activity to reinforce your understanding of the properties, trends, and reactions of the Group 7 halogens.